Hi everybody, this is Miss Elkins. I'm at a conference today, so I'm recording your notes for you. I hope you are having a good day. Let's get started. We're going to talk about intersections of graphed equations. As you know, an equation can be graphed on a coordinate plane as a straight line, or as any other type of line. If you have two equations graphed on the same coordinate plane, the place where they intersect is called the intersection, or the point of intersection. And remember, when you're looking at a coordinate graph, where the two lines hit each other is going to always be a point where the x value comes first and the y value comes second. And remember that when you're trying to name points on a graph, you go from side to side first, and then you go up and down second. So example 1, find the point that satisfies both equations. I'm going to zoom in on this graph so we can see it really clearly. It's obvious to me that these two lines intersect at that point right there. And so I can look on the bottom and I can see that that is the point where x equals 5. And then I can look on the side and I can see that that's the point where y equals 20. So we find where the two lines hit each other. Go side to side first, then up and down second to find the coordinates of that intersection. And as you can see, that line, those two lines intersect at the point where x is 5 and y is 20. And we write that as an ordered pair with parentheses and with a comma in between each number. If you do not put parentheses around it, it's not an ordered pair. It's just a set of numbers from who knows where. So please make sure that you write this correctly with parentheses and with a comma in between each point. All right, let's look at the second example. Example 2, find the point that satisfies both equations. That means, where do these two lines intersect? So I look at the graph and I find the point where those two lines intersect. And I can see that on the x-axis, that point is 18. And I can see on the y-axis that that y value is 15. So those two lines intersect where x equals 18 and y equals 15. It's really just that simple, guys. Okay, let's look at another one. Luckily, I can zoom in for my old eyes. Let's find the point that satisfies both equations. Example 3. Well, those two lines intersect right there. They intersect at the point where x is 4 and y is 2. If you're wondering where I'm getting those numbers here, I'm going straight down from that point and then straight left to right. I'm sorry, straight down from that point and straight left to right. So this is the x value because it's on the x-axis. This is the y value because it's on the y-axis. Just that simple. Don't get those numbers confused though. If you wrote that as the 0.24, well, that would be up here somewhere. And that's not where those lines intersect. All right, let's look at the last example, example 4. Find the point that satisfies both equations. I look at the graph, I see where the two lines intersect, and I just name that point. I can see that that point is, now you've got to look at the numbers, is the point where x equals 2 and y equals 2. Very easy, right? Alrighty. So let's review just a little bit about proportional and functions too, just because that's going to be on your homework. Remember, if it's a function, none of the x values will repeat. So let's look here. A, -6, -3, 2, 4. All different x values. That is a function. All right, look at B, 5, 6, 7, 8, 9. All different x values, that's a function. And then C, -3, 0, 3, -3. Oh, these two are repeated. That's not a function. And if you want to just write yes or no on these, that's fine with me. Yes, it's a function. No, it's not a function. That's perfectly fine. All right, let's look at the next example. Determine if the following is proportional. The way that we know that something is proportional is that it will always include the point 0, 0, or it will go through the origin where x and y intersect. This does go through x and y where they intersect, so yes, this is proportional. That's the only thing you have to look for, is if it has the point 0, 0, if it goes through that point, then it is proportional on a graph. All right. A, determine if the following graphs, or next, determine if the following graphs are a function. Remember, you can do the vertical line test to tell if it's a function. The vertical line just simply means if you are able to draw a vertical line that's up and down through the graph at any point and it touches more than one part of the graph, that it is not a function. And as you can see, I can draw a straight line anywhere on this graph and it will not touch that line that's drawn there, this line, more than once. So this is a function because none of the x values are repeated. Look at B. It only takes one vertical line test to tell me that no, that's not a function because more than one of the x values is repeated. And the vertical line test shows me that I can put a straight up and down vertical line here and it will not, and it will go through more than one point on that line. Sorry. Trying to make this perfect. Not happening. All right, let us look at the next example. Determine the slope-intercept form. That's where y equals mx plus b. Remember, m is the slope and b is the y-intercept. So to write this line, we need to find the slope where we can count rise over run, and we need to find the y-intercept. The y-intercept is easy. It's right here at -1. The slope, I just need to find 2 good points, and I can count rise over run, or I can do the slope formula. If I just count rise over run, and I go from this point to that point, I'm going up 2 and running 3. So my slope is 2 over 3. The equation I need to write is this: y equals 2/3 x minus 1. It's that simple. It's just find the slope and find the y-intercept, and you are good to go. All right, that's the end of our notes today. I hope you understood all this. If you need to go back and watch this again, by all means, please do. Hope you have a great day, and I hope I will see you tomorrow. Talk to you later. Bye.